Hi pre-cal, here's a quick test review video. Number one is given an interval notation, let's change it to put it on a number line. So here's a basic number line, 0, 1, 2, 3, 4, 5, 6, 7. Remember the bracket shows inclusion. That's the same thing as a solid circle. Can put that up above it, and then it goes to 5 but does not include it, so that's one way to show it. Another way to show it is what you're going to see in Math Lab, which would be to put the bracket directly on the number line and the parenthesis directly on the number line, and then shade in between. That's an intersection of two sets. Number two is a union of two sets where we start at infinity, negative infinity, go to -1 inclusive, union, jump over this span, and then start again at 2 and go to positive infinity. That is 1 and 2. Number two, we are going to reduce using properties of exponents. So first thing we're going to do is utilize the exponents that are on the outside by order of operations. A negative exponent simply makes a reciprocal. So 2/3 to the -1 becomes 3/2. A squared to the -1, a to the -2, b to the +3, and c to the +4. We're raising all of those to that power to power. Next, 10 squared is 100. A to the -3rd squared, that's a to the -6th, b to the 8th, and c to the 8th. So 3/2 times 100, just using the commutative property here, a to the -2 times a to the -6th, b to the 3rd times b to the 8th, c to the 4th times c to the 8th. 3/2 of 100 is 150, a to the -8th, b to the 11th, and c to the 12th. Last thing, reciprocate that base to the bottom, 150, b to the 11th, c to the 12th, all over a to the 8th. 1, 2, 3. Next, number 4, solve. Basic quadratic equation. Hoping this one is factorable. I do believe it is. We've got this prime number 7 sitting on the end. So let's go ahead. It's a -7, so let's put 7 here, 1 here. We've got 16 up front, so the options are 1 and 16, 2 and 8, and 4 and 4. I'm going to go with 4 and 4 because that seems to be making the most sense. So 4x times 4x gives us 16x squared. 7 times 1 gives us the 7. We want a 24 in the middle. So if we make -7 times 4, that gives us -28x. And then 4x times a +1 gives us +4x. This is where -24x is coming from. So 4x minus 7 equals 0, 4x plus 1 equals 0, x equals 7/4, x equals -1/4. Solution set. 7/4, -1/4. No restricted values there because there is not a rational equation. Number 5, this is a rational equation, but all of the denominators are integers. So all we need to do is utilize the least common denominator in order to eliminate those fractions. The least common denominator of 2 and 3 is 6. So we are going to multiply the first fraction by 2/2. The second fraction by 3/3, and the third fraction by 2/2, which gives us a common denominator of 6 all the way across, which means now we do not need it. So now we have 2 times x minus 2 plus 3 times x plus 5 equals 2. This, of course, is a very basic one. The next one is a little bit more exciting. Combine the like terms. 5x plus 11 equals 2. 5x equals -9. X equals -9/5. That's through 5. Next, number 6. Another rational equation, but this time a little bit more exciting. Also a reminder, I just finished grading everybody's quick quizzes. There are lots of people that need to review how to factor the sum or difference of cubes, which is what this is. And yes, these are the two factors, but let me review the process one more time. So it's a binomial times a trinomial. And if we're starting out with a difference, then we will start with a minus here because it's the same sign. The opposite sign, always plus. The cube root of x cubed is x. The cube root of 1 is 1. Square the first term, square the last term, and then multiply together, which is, of course, what you get and already have here and there. So play the what's missing game. So what are we missing here? We are missing the trinomial, which is x squared plus x plus 1. And here we're missing the binomial x minus 1. Now, we've talked about in class the importance of remembering that minus sign. I would urge you to just change this to plus -1 so that negative gets distributed right out the gate. Once again, we've established our common denominator all the way across, therefore we're done with it. So 9 and then -1 times x squared, negative x squared, -1 times x, negative x, -1 times 1, -1 equals 2x minus 2. This is a quadratic equation. Let's first of all get the x squared on the other side, make it positive, set it equal to 0, and solve. So 9 minus 1 is 8, so minus 8, and then plus x squared, and then plus the x. So combining like terms again, x squared, and then 2x and x plus 3x, -2, -8, -10. This factors easily. X plus 5, x minus 2, x equals -5 or 2. Now if we go back and think about restricted values, the restricted values is only x cannot equal 1. So both of those should work, being that they're not an excluded value. That's number 6. Number 7, this is an FFCC problem. Factor first before going cancel crazy. You cannot cancel anything until you factor everything. So let's do that here. It is multiplication, so nothing to flip and multiply. So factor the top. 16, so let's see. If we do an 8 and a 2, there's 6, there's 8. 8 minus 6 will give us the 2 in the middle, so we need 8 to be negative and 2 to be positive. So positive 6, -8. -8 times 2 gives us the -16. That's the thought process for factoring. Again, factor. So 2a squared, so 2a, and then we want a 3 in the middle, so 2 here, 1 here to give us a 4 and a 1. So a positive 4, -1. And use a hint from another part of the problem as to what else you might be needing. 6a plus 16 has a common factor of 2. So let's take that out. 2 and then 3a plus 8. Then to the bottom, this is the difference of two squares. So its factors are the conjugates of its square roots. So 3a plus 8, 3a minus 8. These problems are so satisfying when so much stuff cancels, and here it goes. A plus 2, a plus 2, 3a plus 8, 3a plus 8, 3a minus 8, 3a minus 8. What remains, all that remains in the numerator is 2, to the bottom is 2a minus 1. Will those 2's cancel? No. Why? Because you can't factor. Nothing will factor out of that bottom, therefore that is the answer. We do have some restricted values here. So the restricted values are going to be found by the factors of the two denominators. So what can a not equal? It cannot equal 1/2. It cannot equal -2. And it cannot equal plus or minus 8/3. Those are your restricted values. Let's do it again. This time with a division. So we are going to factor everything, and then we will flip and multiply by the reciprocal. A squared minus 6a plus 9 is a perfect square trinomial. So factors of 9 that add up to 6, so a minus 3 squared. To the bottom, the difference of cubes, a binomial times a trinomial. Same sign, opposite sign, always plus. The cube root of a cubed is a. The cube root of 8 is 2. Square the first, square the last, and multiply together. A quick check, does a times a squared give us the a cubed? Yes. Does negative 2 times 4 give us the 8? Yes. Next, times the reciprocal. Look at the denominator here. It is the difference of squares, difference of two squares, the DOTS. So that's 2 minus a times 2 plus a. We talked about this situation in class. To the bottom, factors of negative 6 that add up to negative 1, a minus 3, a plus 2. Everything is factored. Now we can cancel. So 1 power of a minus 3 cancels. A plus 2 is the same as 2 plus a by the commutative property. 2 minus a and a minus 2 are opposites. So when we cancel them, a negative 1 will pop out. So everything else remains. So we have negative 1 times a minus 3 over the trinomial factor, a squared plus 2a plus 4. You can leave it like that, or you could change it to 3 minus a over a squared plus 2a plus 4. Both of those are perfectly correct answers. We've got some restricted values here. A cannot equal, and since this is division, we have to consider restrictions from here, here, and there. So look at all those factors. So a cannot be 2. This, of course, would only yield imaginary factors, so we don't have to worry about those restrictions. 2, already got it. Negative 2, 3, and then negative 2. So those are our restricted values, and this is our simplified expression. Last one, number 9. X plus 2 times x plus 3 equals 20. This is a solve. So this one takes a little work up front. Don't be fooled. It is factored, but since it's going to become quadratic, we must utilize the zero product property. We can't just have it set equal to 20. So let's multiply here. X squared plus 3x plus 2x plus 6 equals 20. Let's bring the 20 over, set it equal to 0. Whoop, I should have combined those terms. I will in just a second. So that is x squared plus 5x minus 14. It will factor once again. Now that it's set equal to 0, we can factor again. X plus 7, x minus 2, x equals negative 7, and 2. That's the solution set. So those are some practice problems that we'll work on, and we'll do some more problems in class to prepare. You're amazing. See you soon.